Hello everyone. So in this video we will study about sinusoid steady state analysis. But before that, let's see some basic things like drawing a sine waveform. All of you must already know it, but just the basic thing. Then we will see how to find the transfer function and all these things. Okay. So let's just first draw the waveform. Okay. So V in T I am drawing. So this axis I am taking as omega t. Okay. This axis I am taking. This is not t. This is omega t. So first is the sinusoid. So simple sinusoid it is. Right? This is how the waveform will look. Right? This is plus Vm. Now what about Vm sin omega t plus phi? So what do you think? When omega t is equals to minus phi, at that time we will be having zero value. So that means it is advanced by phi angle. This waveform is advanced by phi angle. That means it will start phi angle before. So let's just assume this is 0. It is first waveform is starting from 0. So this will start phi angle before. So let's just assume this is your phi angle. This much is your phi. So this another waveform will start from here. Okay, the phi value can be anything. So the another one will start from here. I can use this pen, I guess. Okay, it will have the same maximum value. So it is leading by phi. Are you getting my point? Okay, so this waveform is leading by phi. Leading by phi angle. And if you have to make omega t minus phi, then you will start from here. Let's just assume you are making omega t minus phi, so you will start from here later on. That would be lagging. Got my point? So this is just the waveform. Now there is this simple question. So some V in you are applying, some V out you are getting. So now you are converting that to a system that is having a impulse response. This is what we call it impulse response of a system. Okay, why is it called impulse response? That I will tell you later on, or in signal system you will know it. Impulse response of a system. This is what we call it. Okay, this h of j omega is known as impulse response of the system. So this is nothing but a transfer function. You just need to find the transfer function. So tell me, how do you find the transfer function? For finding the transfer function, what do you do? This is 1 by Cs. This is V naught S R V in S. So V naught S by V in S would be 1 upon Cs upon 1 upon Cs plus R. I have told you to remember this. It would be 1 upon 1 plus RCS. Right? Now what you do? S will be replaced with j omega. This is what you do. This is I can call h of s. My h of s is 1 upon 1 plus RCS. Okay. This is my h of s. Now you need to write it in terms of j omega. Now you need to write it in terms of j omega. So what you will do? You will just replace s with j omega. Okay. So what will be your h of j omega? H of j omega would be 1 upon j omega RC plus 1. So simply what you are doing, first you will find the transfer function and then just replace s with j omega. Okay. So this is your final answer actually, but I will just tell you two more things. What is the magnitude of this? What is the magnitude of? this function. What is the magnitude of a plus iota b? Root a square plus b square, right? So, and what will be the magnitude of 1 by a plus iota b? Magnitude of 1, 1. Magnitude of a plus iota b, root a square plus b square, right? So simply, what will be the magnitude? Magnitude will be 1 upon root omega square r square c square plus 1. What will be the angle? What will be the angle? What is the angle of a plus iota b? That is tan inverse iota, the imaginary value upon the real value. 2 plus 3j, what is the magnitude? Tan inverse 3 by 2, right? This is the angle, right? What is the angle of this now? Angle of 1, that is 0. 1 will be somewhere here, so that is 0. I hope you know the basics. Like, do you know how to write the angles? In AC analysis, that will be taught to you. In AC analysis, it will be taught to you how to write the angle from basics. But if you don't know, I'm just telling you one basic. Like, this is our real axis always, and this is our imaginary axis. And if I'm writing a plus iota b, that means a is the real one and b is the imaginary one. So this is the angle I am talking about. Okay, so the angle would be tan inverse y value by x value. This will be the angle. Okay, and when something is written like this, like 1 by a plus iota b, that means first you are taking the angle of this one. The angle of this one will be on real axis only, no? So it will be 0 degree minus angle of this. Angle of this would be b by a. So final angle would be tan inverse b by a. Got my point? So what will be the angle of this? Okay, these basics will be taught to you in AC analysis as well. Okay, but I just hope you know this much of basics. So angle of 1 will be 0. So 0 minus this value, tan inverse omega rc by 1. In multiplication, let's just assume if I am writing a plus iota b into c plus iota d, and I told you to write the angle. So what you can do, you can write this angle, tan inverse b by a. In multiplication, angles are added. Okay, tan inverse d by c. But in divide, angles are subtracted. Okay, this is the basics only. That's it. And if you are asked to write angle of 2 minus 3j, let's just assume you are asked to write the angle of 2 minus 3j. So where will be 2? 2 will be here. Where will be minus 3? Minus 3 will be here. So basically angle would be minus tan inverse 3 by 2. If you are asked to write minus 2 plus 3j, so where will be minus 2? Minus 2 will be here and 3 will be where? Here. So this angle you are asked. So what you can do? This angle would be tan inverse 3 by 2, but you are asked this angle. So you can do 180 degree minus tan inverse 3 by 2. So from very scratch, it will be taught to you in AC analysis. Okay. Or if you want to know here only, you can just simply Google how to write the angles. How to write angle of a complex quantity. Just go to YouTube, write how to write an angle of complex quantity. Just watch a video, 5 to 6 minutes it would be, you will be able to write the angles. Okay. So basics I have told you how to write the angle. Here, how to write the magnitude, how to write the angle you have written. Okay. Now let's move on to the next concept. That is like, what is an LTI system? This term has been used a lot of time. So once more I am teaching you. So like we are talking about a linear time invariant system. So let's just assume if I apply an input of x of t, I get an output of y of t. To a linear time invariant system, I am applying an input of x of t, I am getting output of y of t. Okay. Now what I am doing, I will be applying different kind of inputs. Let's just assume I am applying x of t minus t naught. Then I am applying alpha x of t minus t naught. Then I am applying alpha x of t minus t naught 1 plus beta x of t minus t naught 2. Then I am applying x to t angle, x to t. Okay. So what happens in LTI system? What is LTI system? Linear time invariant. So if you are shifting in time, similarly your output will be shifted. you are shifting in time by t naught, so similarly your output will be shifted. So this is time invariant. Now it is linear, so if you are increasing the amplitude by alpha, similarly your output will be increased by the same amplitude and same shift will be there. Now if you are adding both of the signals, similarly your output will be added. That's why it is linear, right? These things we have seen in the basics of where did we see it? Okay, it will be alpha y of t minus t naught. We saw it in network theorem actually, right? Also in signal system you will again study it. T minus t naught 2, right? And x of 2t will simply be y. And those placement guys, like those who are watching this video for placements, they don't need to worry. Like it will be like this much only you need to know. When I'm saying you will be studying in signal system or AC analysis, so this is for those who are preparing for gate. They need to know in much deeper manner. So that's for gate, but for placement guys, this much would be enough. Okay. Yeah. Sorry. X of 2t will be in LTI system. X of 2t will be not y of 2t. Like if x of t is giving you y of t response, that doesn't mean x of 2t will give you y of 2t response. Why is it so? Why is it so? Because what did I say? Shifting in time domain will result in shifting in shifting in time domain. But this is scaling. This is scaling, not scaling in time domain will not result in scaling in time domain. Will not result. How should I write? Scaling in time domain will not give the same output. Will not result similarly in the output. Like what I'm saying, like this is my input and I am getting an output like this. Now what I do, I shift my signal. I am shifting my signal, so my output will be shifted. Yeah, that's right. But what I am doing, if my input is something like this, okay, this is 2, this is 4, and my output is something like this. This is my output from 2 to 4. Now what I am doing, I am making it 1, 2. The same signal, just there is a scaling in time domain. So that doesn't mean my output will be like this from 1 to 2. This is not certain. Here I am shifting it. Here I am scaling it. What I did, I just divided this axis by 2. So if this is xt, it will be x of 2t. That means here if I put t equals to 1, I will get the value of 2. Here if I put t equals to 1, I will get the value of x of 2. Right? So if I am scaling my time axis, that doesn't mean my output will be scaled as well. Okay? That doesn't mean my output will be scaled as well. Are you getting my point? So this is one exception of linear time invariant systems. Okay? So this you should know. Okay. So only two things. You can amplify it or you can shift it. Don't do anything with this time t. Okay? Amplify or shift. That's it. So this is my input. Now tell me what will be my outputs. So if I am applying 1 volt input to this RC circuit, you tell me how does the output look like. So first output I should know. If I am applying a step input, how does my output look like? That I should know. So that would be simply an exponential from 0 to 1 volt. This is how my output look like. Now I don't know any concept. I don't know the concept of transient. I don't know anything. I just know this thing. If I apply this input, I get this output. So if I am increasing it, what is this? This is an LTI system, right? This is an LTI system. How it is an LTI system? I have told you R and C, these are linear elements. So it will result in LTI system. Okay. So this is an LTI system. Now if I am amplifying my input to 3 times, what will be my output? Same, just amplified by 3 times. Okay. My output will be the same, just it will be amplified by 3 times. So in case of 1 volt, I will be getting 3 volt. Okay, now in this what I am doing, first I am taking the same input 1 volt, then after some time I am amplifying it to 3 volts. So what will happen in my output? So first I will get 1 volt, 1 volt, then from there I will get 3 volt. So both of the waveforms are superimposed. Here both of the waveforms were superimposed. Similarly, what that is the same thing is happening here. Okay, so this will be 1 volt, this will be 3 volt. Okay, so this is how my waveform will look like for a linear time invariant system. So this is just the basics that I am delivering to you. First I told you the waveforms, what do you mean by phi leading by phi. Okay, then I told you how to write that impulse response. This is known as impulse response of a system. Okay, why is it so, you will get to know later on. Okay, and this is an LTI system. So if I am applying xt input, you will get yt output. If I am applying x of t minus t naught input, you are getting y of t minus t naught output. If I am amplifying my input by alpha, you are getting same amplified version of output by alpha. Then you are adding, you get the addition, and no scaling in time domain. No scaling in time domain is allowed. And this is just an example. 1 volt, so 1 volt, 3 volts. So from 0 to 3, 0 to 1, 1 to 3, and 1, and then 3. Got my point? Let's just see. Now this is our topic, sinusoid steady state response. So this x of omega naught t, I am applying some input to this system, okay, which has an impulse response of h of j omega. Now what will be my output? Okay, so one thing I want to tell you that this x of omega naught t can be three type of function. It can be sinusoid, like sine of omega naught t. It can be cosinusoid, and it can be exponential as well. Okay, these kind of functions are possible. Go to my point. Okay, let it remain here only. Okay, so how will you write the output? Now this output will have two response: steady state response and every output has two responses: steady state and transient response. Now here in this particular case, here I will be only talking about steady state response. Here I will be only talking about steady state response. Okay, we are talking about only steady state response. So output I am writing, but that is steady state output. So what will be that output? Angle of this transfer function, sorry, magnitude of this transfer function at what? At this particular frequency omega naught. Okay, into x of omega naught t minus the angle of this transfer function at a particular frequency omega naught. What is the particular frequency? This particular frequency. What did I do? First what I will do, I will take this transfer function, I will find its magnitude and also the angle. Then instead of omega, I will put omega naught. Okay, I will find the magnitude, I will find the angle, and I will multiply the magnitude and subtract the angle. Oh, sorry, why subtract? Addition, sorry. I will add the angle. Okay, not subtract, I will add the angle. Okay, let's take an example, it will be more clear to you. In this theory, it will not be clear to you. This is an example. I am applying a sine 2t input to a system which has an impulse response of this. And now you need to tell what will be yt. Okay, find yt at steady state. Find yt at steady state. Just notice this. Okay, this is a very important line. Here I am talking about only the steady state response. So this is my steady state response, steady state output. Okay, so what is my h of j omega here? Sometimes instead of h of j omega, they write h of omega as well. Sometimes instead of h of j omega, they write h of omega as well. Okay, sometimes you will see written h of omega. Okay, so don't get confused. So what is h of j omega here? 1 upon j omega plus 1. Okay, so what is the magnitude? That is 1 upon 1 plus omega square. What is the angle? Okay, color, sorry for that, I just, so h of j omega was 1 upon j omega plus 1. So magnitude is 1 upon root omega square plus 1. What is the angle? Angle is minus tan inverse omega, right? Angle is minus tan inverse omega, because the angle here is tan inverse omega and 0 minus tan inverse omega, so angle is minus tan inverse omega. So simply you can write h of omega, h of j omega as 1 upon root omega square plus 1. This is the angle, this is the magnitude, and this is the angle. Okay, now here what is your input? Input is sine 2t. So what is omega naught? Omega naught is 2, right? So what will be your h of j2? That would be 1 upon root 5. Angle will be minus tan inverse 2. What will be your output? Yt. Your output Yt would simply be sine 2t will be multiplied with this. Sine 2t will simply be multiplied with this. So what we will get? What was the magnitude? 1 by root 5, right? 1 by root 5. Sine, angle will be subtracted here, because this is the angle, right? So angle will be subtracted here. So this is my final Yt. So did you get to know what is happening? Look, I will see this function. Okay, 1 upon j omega plus 1. So I will just see what is omega naught. Okay, omega naught is 2. So 2j plus 1. Then I will find the magnitude 1 by root 5. Then I will find the angle. Angle is minus tan inverse 2. Sorry. Minus tan inverse 2. Now what I will do? I will just multiply it 1 by root 5 sine 2t minus the plus the angle is minus tan inverse 2. So that's how I will write the final answer. Okay, here I am explaining, that's why it seems very long, but this is not very long. Okay, omega naught is 2. So from here I can find the magnitude and angle as well. So simply multiply the angle and multiply the magnitude and add the angle. Angle is negative, so eventually it is subtracted. For an impulse response, multiply the magnitude and add the angle. That's it. This is what we need to do. So this is what we see here now. This is my input 5 sin t. Okay, you need to find the value of v naught t. This is my question now. You need to find v naught t. Here yt, this was my steady state response. Just remember it, steady state output. This is my steady state output. Now my switch is closed at t goes to 0. You need to find v naught t. Okay, so let's just find v naught t. So what is my input? V in t or v in omega t I can write. Okay, what is my input? That is 5 sin t. Here omega naught is 1. Okay, what will be my v naught? V naught s, that would be 1 upon 1 plus RCS v naught v in t, v in s. So what will be my h of j omega? That would be v naught of j omega by v in of j omega, and that would be 1 upon 1 plus j omega RC. And since, okay, they should have given the value of RC. RC is 1 second. Okay, and since RC is 1 second, so it would be 1 upon 1 plus j omega. So simply what is happening here is that you are applying an input v in j omega into this function will be your V naught j omega, right? So how do you write the steady state output? How do you write this? This is in frequency domain. This is in the frequency domain. In time domain, what will happen? What is omega naught? Here my V in t is, look, wait, look. This is your V naught j omega is 1 by 1 plus j omega into V in j omega, right? This is the function of frequency domain, not in time domain. This is the function of frequency domain. Frequency domain. In time domain, what happens? First, you need to find, this is your h of omega. This is your h of omega or h of j omega, whatever you say. So, what is your V in t? V in t is 5 sin t. V in t is 5 sin t. That too a steady state. Not a steady state, forget it. Okay, yeah. So, your V in t is 5 sin t. Okay. What is omega naught here? Omega naught is 1. So, you have to find the angle. You have to find h of omega. H of omega will simply be 1 upon 1 plus j. So, how you can write h of omega? H of omega will be, magnitude will be 1 by root 2. What will be the angle? Angle will be minus 45 degree. How minus 45? Tan inverse, minus of tan inverse 1 by 1. Tan inverse 1 is 45. So, angle will be minus 45 degree. Okay. So, angle will be minus 45 degree. So, what will be your y of t? Y of t will be 5 by 5 into this magnitude 5 by root 2 sin t minus t plus this angle is 45 degree, t plus this angle, t plus minus 45, so minus 45. Okay, so y of t is this. So this is what? This is my steady state output. This is only my steady state output. Okay, forget it. Let's not write it. Okay, so I am saying this is my yt. Okay, now at t equals to 0, what do I expect? At t equals to 0, you want your V naught 0 plus equals to 0 volt, right? At t equals to 0, the capacitor is initially having 0 voltage, so you expect your output to be 0 volt, right? At t equals to 0, yt, instead of yt, I should write V naught t. At t equals to 0, capacitor will have 0 voltage, right? At t equals to 0, capacitor will have 0 voltage. So you would want V naught 0 plus equals to 0 volt. At t equals to 0 plus, you would want your V naught to be 0. Now over our, now our V naught t is 5 by root 2 sin t minus 45 degree. If I put t equals to 0 here, at t equals to 0, what do you get? V naught 0 plus at t equals to 0 plus. What do you get? Sin 5 by root 2, 5 by root 2 sin minus 45 degree. So it would be minus 5 by 2 volt. So from your V naught t, you are expecting minus 5 by 2 volt. But in actual, this output will be 0 volt. So this V naught t that you calculated is wrong. First, what did you say? You expect your output to be 0 volt at t equals to 0. But when you put t equals to 0 volt in this function, what do you get? When you put t equals to 0 volt in this function, what do you get? Minus 2.5 volt you get. You get minus 2.5 volt. If you put t equals to 0 in this function, you get minus 2.5 volt. So, what did I say? This V naught t is your only steady state response. So, V naught t, this V naught t is not your final output, is not your final output, but steady state response. So you should write V naught T steady state is 5 by root 2 sine T minus 45 degree. Okay, so this is just the steady state response. Now how to find transient? Now what will be my V naught T transient response? How do you find that? So by putting T equals to 0, you are getting minus 2.5 volt here. But in actual, V naught 0 plus is 0 volt. So there would be some transient that kills this minus 2.5 volt. What I mean to say is that from steady state response, at t equals to 0, you are getting minus 2.5 volt. But conceptually, V naught 0 plus should be 0 volt. So there has to be some transient response. Some transient response that kills out minus 2.5 voltage. So what will be your V naught T transient? So at t equals to 0, you need plus 2.5 voltage more. So your transient would be e to the power minus t by tau, and here tau is the time constant of the circuit, that is RC. Right? So what is your V naught T finally? That is 5 by root 2 sine t minus 45 degree. Okay, first you calculated your steady state response, then you go to know at t equals to 0 you are getting minus 2.5. That means there has to be some transient that gives you plus 2.5, and eventually that transient will die out. So this is your final response, and you will connect one, you will add ut here because the switch was closed at t equals to 0. So this is your final response. Are you getting my point or not? This is a very important thing. Many times I have seen, I ask this question in interviews as well, in some mock interviews. So many times I ask, this is the circuit given to you, what will be your final output? And everyone calculates this. Okay, first what they will do, they will find that transfer function, then they say that magnitude is 1 by root 2 and angle is minus 45. So 5 by root 2 sine t minus 45 degree. Then I ask them, check the value at t equals to 0. That is minus 2.5. But what do you expect? You expect that voltage to be 0. So this is not the final response, this is just the steady state response. That's why I was again and again focusing on this point, steady state. Okay, why out? Steady state output. This is what? This only gives me the steady state response, not the complete response. So there has to be some transient available. Okay. So when I calculated it, I got to know because of the steady state, I am getting minus 2.5. So there has to be some transient that kills out this minus 2.5, and that would be minus 2.5 e to the power minus t upon tau, because eventually you want your transient to die out. So basically what is happening here is that there are two responses involved. Okay. There are two responses. This is your minus 2 plus 2.5. Yeah. So this is your transient one. Okay. And there is one more, this one, minus 45 degree. From here it will start lagging, minus 45 degree lagging, right? And maximum amplitude is 5 by root 2. So 5 by root 2 is greater than 2.5 or less than 2.5. Since root 2 is less, then it will give a greater value. So 5 by root 2 is greater than 2.5 actually. Okay. So basically at from here it will start basically. So it will since it is greater than so your final output will simply be addition of these two waveform. Okay, this is your steady state response. Steady state response. So basically, if you add these two, at t equals to 0, you are getting minus 2.5. So it should look like something like this. If you add these two, you will get a new waveform. So steady state response and transient response. So this is this transient is 2.5 e to the power minus t upon tau, and this is that steady state. If you add these two, this is plus 2.5, this is minus 2.5. If you add these two, there will be some waveform that starts from 0 and some frame some sinusoid, and at steady state, after some time at steady state, it will be following this waveform only. Okay, so are you getting my point? So this is your final output, addition of two waveforms. If you add these two waveform in some function you can do in MATLAB, you can plot this. You need to add these two waveform and you can see how does your final output look like. So initially it will be something different. It won't look like a pure sinusoid, but once you have after some time, like what was the tau here? Tau is RC and that is equals to 1 second. So after 5 seconds you will realize that it is looking like a pure sinusoid. Initially it won't be a pure sinusoid because this function and this function is added, right? But after 5 seconds, because it will take 5 to time to settle down. So after 5 seconds you will get to know, you will see that it look like a pure sinusoid because this is a pure sinusoid only. So after 5 seconds it will look like a pure sinusoid, but before that it will be a kind of mixture of sinusoid and a exponential response. Okay, so I can't really plot it, but you can plot it in some MATLAB software or anywhere. Okay, so yeah, so this is how your final output look like. Okay, addition of both of them. So always remember, whenever they are asking you these kind of questions, so first what you will do, first you will find the steady state response, then you will see at t equals to 0 what do you expect. At t equals to 0, here I was expecting 0 volt, but because of the transient response I am getting, minus 2.5 volt. So there has to be, sorry, because of the steady state response I am getting minus 2.5 volt. So there has to be some transient that kills out this minus 2.5. So that would be the positive of 2.5 e to the power minus t upon tau. So eventually it has to die down. After 5 tau it will die down, only this will remain. So this is the steady state output. This is the steady state output and this is the transient output. Okay. So this is how you will write your outputs. Okay, and you can solve this by applying differential equation as well. Like you just apply a differential equation, V in equals to C dvc by dt into R plus Vc. Okay, what I am saying, V in equals to, what will be the current? C dvc by dt, C dv naught by dt. So R into C dv naught by dt plus V naught t. Then just instead of V in t, what you will put? You will put 5 sin t. Right, 5 sin t. So by solving this differential equation as well, you can get the value of V naught t, and this is what you will get. This is what you will get. Okay, but instead of solving differential equation, we will prefer this thing. Okay, first find the steady state output and then see there will be some transient. So let's solve another question. Here V in t is 5 sin t ut. Okay, it should be 5 sin t ut. We are starting from t greater than 0. Okay, it is 5 sin t ut. So R value and L value are given 1 and D. You have to find IT. Okay. So first what we will do, we will find in S domain. So what will be your I of S? I of S will be R plus LS into V in S. So what is your transfer function basically? H of S, that is R plus LS. H of S is I in upon V in S. Right. So basically what you are doing, replace S with j omega. So R plus j omega L what you are doing, you are giving an input that is your voltage V in j omega, and you are getting an output that is a current, I of j omega, right? So wait, output by input R plus j omega L, is it fine? What will be your V out? What will be your IT? IT will be, oh yeah, there is this I wrote wrong. Okay, V in S is equals to R plus Ls I in S, right? That's what I was thinking. So Is by V in S, that means H of S, that would be 1 by R plus Ls. And if I am talking about H of j omega, that would be 1 upon R plus j omega L. Okay, and if you put R and L equals to 1, so it would simply be 1 plus j omega, right? So what is your H of j omega? That is 1 plus j omega. What is given omega naught? 5 sin t. Input is V in t is 5 sin t, right? So your omega naught is 1 here, radian per second, unit is radian per second. So what will be your H of omega? H of omega will be 1 plus j. So the angle will be, sorry, the magnitude will be √2 and angle will be 45 degree, plus 45 degree this time. Okay, so what will be your current? IT. Current IT would be 5 into √2. Wait. This is not, again and again I am doing this mistake. I forgot to 1 upon R plus j omega L. Here I will write. So it would be 1 upon 1 plus j omega. One upon 1 plus j omega. Okay, so H of j omega is 1 upon 1 plus j omega. So what is the magnitude? J, not I should write j omega, j1 I can write. H of j1 I can write. J1 because omega naught is 1 only. H of j1 would be, this is the magnitude and this is the angle. Okay, so what will be your I of t? That would be, what is input? 5 sin t ut. So 5 by √2 sin t minus 45 degree, but this is just a steady state response, right? Now what do you expect at t equals to 0? At t equals to 0 plus IT steady state. What is IT steady state? That is minus 5 by 2. That is minus 2.5. Look, you will not do these kind of things in the exam, right? What you will do? You will see that what will be your I of S? I of S will be I of j omega. I of j omega will be voltage upon the total impedance, that is R plus j omega L. You know the value of R and you will simply write 1 plus j omega. 1 plus j omega. In time domain, what will happen? What is the omega naught? That is 1. So 1 by √2 into 5 into sine t minus the angle. This will be my IT. That's how I will be doing in the exam, right? This is the, like, this is I'm teaching here, so that's why I need to write like this, right? First I am finding transfer function, but this is not you are going to do in the exam. You will just see in the exam, oh, what is my output? I of j omega is basically V of j omega by 1 plus j omega. So how I will write IT? So this is how I will be writing IT. So from next time onwards, I will be doing this thing only, because from next time onwards, we will be seeing some questions. So this is how I will be solving, not like finding transfer function and everything. You don't need to find transfer function on all these things. Just find the relation between input and output, and from there you can write. Okay. So this is your output, and at t equals to 0 plus, what you are expecting? Minus 2.5 ampere current. But conceptually, what will be the current? conceptually, what should be the current at t equals to 0? Inductor doesn't have a current initially, so 0 ampere, right? So there has to be some transient. So what will be your IT transient? That would be 2.5 e to the power minus t upon tau ut, right? Where tau is L by R, that means 1 second. Okay, so your IT will simply be 5 by root 2 sin t minus 45 degree plus 2.5 e to the power minus t upon tau ut, right? So this will be my IT. This is my final output. Got it? So in exam, I will be solving it very quickly. I will find 5 by root 2 sin t minus 45 very quickly. Then I will see what is the value at t equals to 0. That is minus 2.5. But I expect 0. So I will put e to the power minus t upon 2. Like in the final function, here if you put t equals to 0, what do you get? In this function, if you put t equals to 0, it is 0 ampere only. If you put t equals to 0, it will be minus 5 by 2 and it will be plus 2.5. So minus 5 by minus 2.5 plus 2.5 is 0 only. So at t equals to 0, you are getting 0. So this is the final output. Did you get my point? Have you understood the complete concept? Whatever that I have told you in this lecture, whatever that I have taught you in this lecture, have you understood everything? First, we studied about LTI systems. What are LTI system, or some simple waveforms we saw in LTI system we saw. Then we saw how to write the steady state response. Just find the relation between input and output. Then you need to write the magnitude and the angle. That's it. That's how you write the steady state response. And then we go to know in RCRL circuit, only the steady state response will not be there. There will be some transient response as well. Okay. So now we will see this question. Yeah. So let's see this question. So in this question, your switch is being closed at t equals to t naught. Okay. Now what does that actually mean? Let's just assume this is your sine wave, right? This is your input 5 sin omega t. So this input is running from t equals to 0. Okay. And let's just assume something is t equals to t naught. This is t equals to 0. So here this switch is being closed. Are you getting my point? Let's just assume at t equals to t naught you are having, this is 5 sin t, let's assume you are having 4 voltage. So at t equals to t naught you are giving this RC circuit a 4 volt and then it will follow sine wave. Are you getting my point? Like people may think, like let's just assume t naught is 2 seconds. So they may think like, what do you mean by t equals to 2 seconds? So this is with respect to the sine wave. The sine wave is running from t equals to 0 or t equals to minus infinity actually. The sine wave is running like this. It is running continuously from t equals to minus infinity, but at some time t naught you are just closing the switch. This is what t equals to t naught means. Okay. Let's see the question now. The switch is being closed at t equals to t naught. You have to find the time t naught such that your v naught t doesn't have any transient response. Okay. So let's just assume I turn on the switch. So if I turn on the switch, what does my RC circuit see? My RC circuit see that there is an input applied, that is sinusoid. So it will give the response like that. So what will be my steady state response? What will be my V of j omega? V of j omega will simply be 1 upon 1 plus j omega RC. RC value should have been given. Again, I forgot to write. RC is 1 second. Okay, RC value should have been given there. RC is 1 second. So j omega RC V of j omega. This is what it will see. Now what will be my omega is omega naught is 1. RC is 1 second. Right? So what will be my V naught t? My V naught t will simply be, what will be the magnitude? Magnitude will be 1 by root 2. Right? The same question we have solved. What will be the angle? Angle will be 45 degree. So this will be my V naught t. Right? I just apply an input, I just close the switch and this will be my V naught t. Now V naught t a steady state. At steady state. Now they are saying, when should I at steady state? Now they are asking, when should I turn on the switch so that in my output there is no transient? When there will be no transient? What does this capacitor think? That my initial voltage should be 0, right? When you turn on the switch, turn on the switch, capacitor will want zero voltage across it, right? Zero voltage across it. What do I mean? That V naught at t equals to 0 minus should be equals to V naught at t equals to 0 plus, and that should be equals to 0 volt. Now my steady state response is my final response because I don't want any transient. Basically at t equals to t naught, I want my output to be 0. Are you getting my point? So 1 by root 2, if it is not 1 by root 2, it will be 5 by root 2. This would be 5. So at t equals to t naught, I want my output to be 0. That's it. So 5 by root 2 sine t naught minus 45 degree should be equals to 0 volt, right? So my t naught would be, this is in degree, so in angle it would be pi by 180 degree. So it would be, t naught would be, like in time we have to find in radian, this is in angle, so we have to find in radian, so it would be pi by 4, so 3 point, I need to bring a calculator, wait. So my t naught is 0.78 second. Okay, so at t equals to 0.78 second, if I turn on the switch, my circuit will not have any transient response. Did you understand the problem actually? Initially, what is there, like this is my sine wave. This is my sine wave which is running from t equals to minus infinity, it is just running, right? What I do at t equals to t naught, I turn on my switch. If I had turned on the switch at t equals to 0, what my RC circuit would see? My RC circuit would see there is a sinusoid input. Based on that, it will give me a response. The response that it gives me, this is like this. Then I got to know at t equals to 0, my sinusoid, my steady state response is giving me minus 2.5 voltage. But at output, I am expecting 0 voltage. So that's why I need to add plus 2.5 transient as well, right? Plus 2.5 e to the power minus t upon 2. But now what I am doing, I'm not closing the switch here. I'm closing the switch here. Now if I'm closing the switch here, after some time, what my RC circuit will think? My RC circuit will see this input only. My RC circuit will see this input only. And based on this input, it will give me an output. Right? Also, here I should add u of t minus t naught as well. Okay? There will be no change in this. Like you can't do sine t minus t naught 45 minus 45 degree, because this is not seeing this input. My input is sine t. Are you understanding the difference? My input is sine t only, but I am turning on the switch at t equals to t naught. I didn't write my input is sine t minus t naught u of t minus t naught. I did not write it. My input is sine t only. So if I am applying it, it is seeing sine t is applied, and based on sine t, it is giving me the response. So this is the final response it is giving me. And why did I add u of t minus t naught here? Because after t naught time only I will get the response. Before t naught time, there was no charge on the capacitor, so it will be 0 only. So after t naught time only I will get the response, right? So this response will be there after t naught time only, and the t naught value that I am getting is 0.78 second. So basically my v naught is this 5 by root 2 sine t minus 45 degree u of t minus t naught, right? So after t naught time only I am getting this response. Before t naught, my response is 0 volt, and you can't put t minus t naught minus 45 degree here, because what my RC circuit will see? My RC circuit will see only a sinusoid input, that is 5 sine t, and based on that it will give me a steady state response. When I saw this steady state response, I got to know that at t naught time, at t equals to t naught, what is my t naught? That is 0.78. So if I put t equals to 0.78, in what equation? In this equation, 5 by root 2 sine 0.78 minus 45 degree u of t naught minus t naught. So this will be simply 1, and this function will be 0. So at t equals to t naught, I am having zero output voltage, and this is what I want. So there is no need of adding any transient. Are you getting my point or not? Just pause the video and think about it, what I am saying. This is a very good question. These kind of questions should be asked in gate or written test, or even in the interview very soon. These kind of questions are being introduced very soon. Okay. So are you getting my point, what I am saying? I am closing the switch at t equals to t node, so that I am having no transient, like only the steady state output. Even in the steady state output, what I am seeing is that at t equals to t node, my steady state output is 0. So I don't need to add any transient. Did you get this question? Let's solve more questions. Okay. You will understand more by that. Okay. So this is the question. Now the switch is at position 1 for a very long time. Now it is moved to position B at t equals to t naught. Find the value of t naught such that the current IT is transient free. Okay. Switch is at position 1 for a very long time. That means I of, wait, the switch is at position 1 for a very long time. So let's just call this current as I dash t. So now this for t less than 0, for t less than t naught. The switch was at position 1. So this was the condition, and it was there for a very long time. So steady state would have been reached, right? So steady state would have been reached 5 10 ohm 1 Henry. Steady state would have been reached. Right? So what will be the value of current I dash for t naught minus? That would be, the inductor will be shorted, right? So that would be 5 by 10, 0.5 ampere. Now what will happen for t greater than 0? For t greater than 0, this inductor 1 7, this is 1 Henry, which is initially having some current, that is 0.5 ampere, right? This is having initially 0.5 ampere, and this R is 7 ohm, and this is 5 cos t, 5 cos 2t, and angle, one more angle is, that is 30 degree. So what does this RL circuit see at t equals to t, oh sorry, for t greater than t naught, not t greater than 0. So at t equals to t naught, this RL circuit sees an input, that is 5 cos 2t plus 30 degree, and based on this input it will give me a steady state response. Whatever the input it sees, it will give me a steady state response. What is this? This is our IT, right? So what will be my IT steady state? IT steady state I can find. Based on this input, it will give me a steady state response. So first thing is that I can find IT steady state. So basically my 5 cos 2t plus 30 degree I of j, instead of 5 cos 2t I can write V in. Okay, I am just calling it as V in t. V in of j omega is equals to I in of j omega to R plus j omega L, right? So my I in of j omega would be V in of j omega by 7 plus j omega L. Here what is omega naught? Omega naught is 2 radian per second. And did I give the value of R and L? Yeah, R and L value are given. Instead of L I should put 1 only. This is L is 1 only. Considering L equals to 1 Henry. L is 1 only, and omega is 2. So basically what will be my amplitude? Amplitude will be 49 plus 4 root 53. So 5 by root 53. Are you able to write it, right? You are able to write it. 5 by root 53. This is the angle. Sorry, this is the magnitude. What will be the angle? Cos 2t plus 30 degree. Angle will be subtracted. That will be tan inverse 2 by 7. Did you understand what did I do here? Tan inverse 2 by 7. This is the steady state response I am writing, nothing else. 5 by omega naught is 2. So what will be the magnitude? 49 plus 4 root 53 cos 2t plus 30 minus angle. Angle will be tan inverse 2 by 7. So this will be my I of t. This will be my I of t. Now at t equals to t naught, to get a transient free response, what do you expect at t equals to t naught? Current at t equals to t naught should be what? 0 ampere. Current should be 0 ampere or what? Current should be 0.5 ampere, right? Current should be 0.5 ampere because at t equals to 0 minus it was 0.5 ampere. So inductor will hold its current. So it should be equal to 0.5. So this value should be equal to 0.5 ampere. Okay. So 5 by root 53 cos 2t minus 30 degree 2t naught actually at t equals to t naught, this value should be equals to 2t naught plus 30 degree minus tan inverse 2 by 7. If I am writing this correctly or there is something wrong, omega naught is 2, so yeah, angle will be 2 root 2 by 7. This should be equals to 0.5. So from here now I can get the value of t naught, but make sure this is in degree, so you need to convert it in radian. So instead of 30 degree I will be writing pi by 6, right? So now I have to calculate. So what I will do, 0.5 into root 53, 0.5 into root 53 by 5 cos inverse plus tan inverse 2 by 7 2 by 7 tan inverse 2 by 7, okay, minus pi by 6 okay, divide by 2. So I am getting 0.255. T naught is around 0.26 second. Okay, let me recheck it. Actually these kind of calculation can go wrong if you do it in one step only. So this can go wrong, so let me recheck it. Yeah, so this calculation was correct. I am getting 0.26 second. So whenever you do these kind of complex calculation in exam, no, so you should recheck, like just put this value here and then check what you are getting, right? So this is how you should recheck at least once in the exam. So did you understand this question, what it was saying? So what did I do? I got to know my initial current in the inductor is 1 ampere, 0.5 ampere. Then I am giving it this this cosinusoid. Okay, so now this RL circuit will see this cosinusoid, and based on this it will give me a steady state response. So this is my steady state response. Now I want it to be transient free, so that my IT is transient free. Now when it will be transient free? It will be transient free if this is sufficient for me. If this is sufficient for me, this is my steady state. My steady state is sufficient for me. And when my steady state will be sufficient? If it provides me 0.5 ampere current at t equals to t naught, right? Because at that time I need my current to be 0.5 ampere. So at t equals to t naught, I want my current to be 0.5 ampere. And if I put T equals to T naught here, it should provide me that same amount of current. So I am putting T equals to T naught and it should provide me 0.5 ampere current. Okay. Here you need a bit more brain of yours. Okay. So be attentive and just think what I am saying. I hope you are understanding. Now the next problem will be addition of all three. Okay. So there can't be any problem, like nothing more can be asked in this topic. Okay. In first, what did we see? No initial current. Then we saw what should be the value of T naught. Now there is initial condition. Then we saw what should be the value of T naught. Now there is initial condition. Also I have transient as well. So what should be the value of T naught now? Now value of T naught is given, but what should be this angle? That I am asking. Or I could have asked the value of T naught as well. So this will be a complete analysis. So what is happening here? This switch is closed for a very long time and it is opened at T equals to 2 seconds, and this switch is closed at T equals to 2 seconds. What is happening? This switch was open for I will make the circuit on next page. So for T less than 2 seconds, what was the condition? This switch was closed, this switch was open. So forget about this, just think about this, right? Here the applied input is 5 ut. That means it is starting from 0, right? Input is starting from 0. This is the condition. 1 farad capacitor, and this will be your Vt, right? 1 ohm, 1 ohm, 1 ohm and 1 ohm. What will be Vt? Vt will be 5, not 5. You should be able to write initially 0 voltage. At steady state, it will be 2.5. 2.5, 1 minus e to the power minus t upon tau. What will be the value of tau? T upon tau, what you will add? Ut. Because the input is starting from t greater than 0. So this is the condition for 0 to 2 second actually. For 0 to 2 second. Right? Because for t less than 0, even this input is not there. So no charging, no discharging, nothing is happening in the circuit. From t equals to 0, something is starting to happen. Right? So this is my Vt with time constant being 1 by 2 second. No, sorry. What is R equivalent? R equivalent is 1 by 2. What is C? C is 4 farad, not 1 farad. This is 4. So that is 2 seconds. Okay. So now this circuit is remaining there. The switch is there for 2 seconds only. So I will be interested in finding the value of V at t equals to 2 seconds. So what is that value? 2.5 into 1 minus e to the power minus 2 upon 2. Right. So it would be why am I interested in this voltage? This will be 1.58 volt. Why am I interested in this voltage? Because this voltage will be carried forward, right? Because capacitor will have its initial voltage. Now what is happening for t greater than 2? T greater than 2 seconds. What is happening? This switch is being closed, right? Calculator is closed now. So that switch is being closed. So what I will do? This is the capacitor that I have. 1 ohm. This is 4 farad. This is 1.58 volt. This is 1 ohm resistance. What is the applied input? That is 5 sin 2t. 5 sin 2t plus 5. Now what will happen? This RC circuit will see this input, and based on that it will give me a steady state response, right? This RC circuit will see this input and it will give me a steady state response. Just write that steady state response first. So what will be my steady state response? What will be my Vt? V of j omega will simply be V in of j omega upon V in of j omega. Forget about the initial condition, everything. Just write the steady state response. Right? While writing the steady state response, no initial condition, nothing you need to consider. Only the steady state response you are writing. So forget about 1.58 volt. just 1 upon 1 plus RCS, that you know. So V in upon j omega RC, right? RC value is 4, so you can put 4, and omega naught is 2. In omega naught is 2, RC value is 4 second. Okay, this is V in, I should put V of j omega 1 upon 1 plus 8j V in of j omega, right? So what will be the magnitude? Magnitude will be 1 by root 65, and sine 1 by root 65 into 5, 1 by root 65, let's just put it 1 by root 65, and what is the input? That is 5 sine 2t plus 5, and one more angle will be subtracted, that would be minus tan inverse 8, right? So this tan inverse 8 is subtracted. So this is my VT, that is voltage across the capacitor. Now what the question is saying, the VT has a transient component of maximum amplitude of 0.5 volt. This is what? This is my steady state output. I should put here U of t minus 2. Why am I putting U of t minus? Not here. I can't put t minus 2 here. Why I can't put? Because what the RC circuit see? RC circuit will see only 5 sine 2t plus 5. No t equals to 2 seconds, nothing matters to it. Whatever the input is applied, because this input is starting from t equals to 0, not from t equals to 2 seconds. This is not starting from t equals to 2 seconds. It is starting from t equals to 0. So it will see this input, and based on that it will give me a transient final steady state response. Now what the user requires, the user is saying that my VT should have a transient component of maximum amplitude of 0.5 volt. That means I need a transient response of 0.5 volt. Okay, so what actual output I need? Actual output required. What should be the actual output? That is, this component will come there, that's for sure. Sine 2t plus 5 minus tan inverse 8 plus I need 0.5 transient as well, and t upon tau. Tau is 4, I guess. Tau is 4. And tell me, what will I put here? T upon, shall I put e to the power minus t upon tau, or shall I put e to the power minus t naught upon tau? Just pause the video and think about it, then only you will watch the video. What should I put? This or this? I should put this. Why? Because my transient will come after t equals to 2 seconds only. It's not that my transient is starting from t equals to 0. When I turn on the switch, at that time transient will come. This is the steady state response. It will just see the input and give me a steady state output. My input is 5 sine 2t plus 5. That is starting from t equals to 0. Right? But what about the transient? Transient will come when you turn on the switch. So I will not write t equals to, I will not write here t. I will write t minus 2 by tau. And whole u of t minus 2. So now what do you need? At t equals to 2 seconds, what do you need? At t equals to 2 seconds, V at 2 seconds should be, V at 2 seconds should be what? 1.58 volt. Because it should carry its initial voltage, so it should be 1.58. It should be 1.58. The voltage across the capacitor should be 1.58. Now you are saying 0.5 is provided by my transient, so rest of this provided by this steady state response. Are you getting my point? Without using the equation also you can see, right? What do you see? First you will write the steady state response, then you will see that, okay, I need 0.5 transient. That means rest of that part should be provided by the steady state response. So basically what I will do, I will put t equals to 2 and I will put it equals to 1.58. Right? So basically 5 by root 65 sine 4 plus 5 minus tan inverse 8 at t equals to 2 second. At t equals to 2 second, this is providing me 0.5. Transient is providing me 0.58 voltage. So rest of the voltage will come from this part, right? So this part should be equals to 5 by root 65 sine 4 plus 5 minus tan inverse 8 1.08. So from here I will get the value of 5. Okay, so I guess I have calculated it. I get around minus 138, but I am not really sure. I will calculate again. Okay, so 1.08 into 65 root divided by 5 sine inverse. There is something, some error is there, because it is giving me sine angle is giving me value greater than 1. So there is some error. I have committed some mistake. What is that mistake? Okay, so look, if I put 5 here, no, if I put 5 here, this value is becoming equals to some 1.74. So the question itself is wrong, because it cannot happen, right? So I have to change the question such that here my input is 50. Okay, that is 50 sine 2t plus 5. Okay, my input is 50. I have to change it like this. I have to change it. Input is 50. This is 50. Okay, 50, 50. Let me check if I have to change somewhere else as well. Yeah, it will be 50. Okay, so now I can solve the problem. 1.08 into 65 under root by 50 sine inverse plus tan inverse 8 minus 4. This is the angle I am getting in radian. Now I need to convert it into degree by minus 136. Pi is minus 136.27 degree. Okay. So there was a slight change in the question that the applied input is 50, not 5. 50 sine 2t plus 5. So what this question was saying, initially the capacitor was it was on for 2 seconds, so the capacitor was charged for 1.58 volt. Now it is charged for 1.58 volt. It is seeing this voltage 50 sine t 2t plus 5. So based on this voltage, it will give it a steady state response. Based on that, it gives it a steady state response, and this is what it gets. Okay, but what was the actual output required? It is saying that I should have a transient component. Now my transient component is not 0. If my transient component was 0, I should have put this value to 0. But it is saying that my transient component, sorry, if my transient part was 0, if they were saying that your transient part is 0, then what you would do? You would put this equation to 1.5, right? 1.58, because only the steady state response should provide you the complete initial voltage, right? Only the steady state response should provide you the complete initial voltage. But now 0.5 is provided by the transient, rest of the voltage should be provided by the steady state response. So 0.5 is provided by the transient. What is the rest? Rest would be 1.58 minus 0.5. That means 1.08 should be provided by the steady state response. So the angle has to be minus 130 degree, minus 136.27 degree. Did you understand the complete concept? This was the last question of this. So I hope you have understood the complete concept of transient, AC transient. We call it in AC transient or sinusoid response. So I have seen most of the students studying till this point only, that this is the steady state response, that's it. No, steady state response, then it have a transient as well. So we have to find the transient response as well. Then we saw one more question. Then we saw in this question, you need zero transient. So I have seen some student mugging up some formula that if sinusoid is applied, this would be the formula. If cosinusoid is applied, this would be the formula. If voltage is asked, this would be the formula. Current is asked, this would be the formula. No formula, simply the concept. Just find the steady state value, and now they are saying it shouldn't have any transient component. Initial value should be 0. So this value should provide me 0 output at t equals to t naught. So from there I can find the value of t naught. In the next question, what they were saying, the inductor was initially having some current that was 0.5 ampere, and the current IT, this current IT should have no transient component. If this current IT should have no transient component, that means the steady state response itself should provide some current. So the steady state response, that was this should be put equals to the initial current, that is 0.5. So from there I got the value of t naught. Now in the last example, what they were saying, initially the capacitor is charged to some voltage, that means it is having initial voltage. Now there is some transient component as well. So 0.5 voltage is provided by the transient component. Now rest of the voltage should be provided by the steady state response. So what is the steady state response? This is the steady state response. So this should be provided by 1.08 should be provided by this steady state response. And one more thing, you will never do anything with that steady state response, because input is applied at t equals to 0 only. You are closing the switch at t equals to t naught. That doesn't mean you will change the input. The input will remain there as it is, because it is being applied at t equals to 0. If I am saying sine omega t, that means it is starting from minus infinity and it is going on, right? It is starting from minus infinity and it is always going on like this, whatever the waveform it is. So it doesn't mean the sinusoid will start from t equals to t naught. It is going there. Now you are closing the switch, that means now this waveform is coming. Okay, and in case of steady state analysis, what input will see? Input will simply see 4 sine omega t plus 5, whatever the voltage we have applied. It doesn't see it is applied at t equals to t naught or what, because at steady state this doesn't even matter at what time you close the switch. Are you getting my point? I hope you have understood the complete concept. This was a very good concept as well. And in the next 2 videos, we will see all assignments only. Okay, the complete theory part is completed for transient response. There can be nothing more that can be taught in this topic. We have started from RC, RL, RLC, LC, and this sinusoid response. So these 5 topics we have covered very, very deeply. And I hope you have enjoyed the lectures very nicely, right? So please do share it with your friends. And this was one concept that is not much discussed. So here I thought of discussing it in much deeper manner. Okay, then let's meet in the next video with the assignment. Okay, thank you.